Welcome to the CyberBrief Project. This series helps defenders and curious minds understand how attackers think, what they target, and how to see threats differently. Today we examine a campaign where attackers delivered Cobalt strike by weaving their path through websites people already trust like GitHub, Quora, and Microsoft's own community pages. Cobalt strike is a professional penetration testing tool, but attackers often abuse it because once deployed, it gives them the same powerful controls security teams use to simulate real breaches. At first glance, the platforms in this attack look harmless, but in this case, they became the hidden delivery chain for one of the most widely used offensive tools. So let's begin today's episode and walk through how this attack unfolds step by step. The story begins with an email. It looks like routine business, a polite request for product information, a set of requirements, and a company profile. To the recipient, it feels completely normal. The email carries an archive. Inside, the recipient sees two PDF documents that open just fine, reinforcing the illusion of legitimacy. But inside the same archive sits a shortcut. When clicked, that shortcut silently places extra components on the computer and launches an executable program. A few seconds pass. The executable that runs is not suspicious malware, but a real crash reporting tool, the kind developers use to collect data when applications fail. To the victim, nothing appears unusual, but the attacker has already laid their groundwork. From the very beginning, the attacker planted a malicious companion library, a DLL file, next to this executable. When the program launches, it automatically searches for the library it depends on. It finds the attacker's version and loads it without question, because it assumes the file is legitimate. In that instant, a trusted application becomes the carrier for malicious code. The danger comes not from the executable itself, but from the attacker's library riding alongside it. Trust in one familiar program is what gives the malicious code its opening. Once loaded, the malicious library conceals its activity. It hides the functions it uses, reveals them only at the moment they are needed, and wipes them from memory immediately afterward. To security tools, almost nothing looks suspicious. The library also changes the way one of the executable's normal functions behaves. Each time the program calls it, the attacker's code intercepts the call and runs instead. Through this redirection, the program quietly reaches out to the internet. The connection does not go to shady or unknown servers. Instead, it reaches trusted websites, a Microsoft Tech community page, a GitHub repository, even a Quora profile. Hidden in the HTML of those pages are short, encoded strings. To a casual visitor, the profiles look empty or harmless. To the malware, they act as secret instructions. And this is why the camouflage is so effective. Security teams see traffic to GitHub or Microsoft and assume business as usual. By placing their instructions inside platforms that companies already rely on, the attackers turn trust itself into their disguise. The victim's computer downloads and decodes those instructions. Security logs only show traffic to familiar domains, so nothing raises suspicion. Yet these trusted platforms now serve as waypoints in the attacker's chain. The decoded instructions contain the address of a real download location, for example, a raw content page on GitHub. From there, the executable retrieves an encrypted shellcode, decrypts it, and relaunches itself with special parameters. This cycle repeats until the final payload is ready to run. At that point, a reflective loader takes over. It injects Cobalt Strike Beacon directly into memory. Cobalt Strike is a legitimate security testing framework, but in the hands of attackers, its beacon becomes a full-featured agent. It can execute commands, move across systems, harvest credentials, and quietly exfiltrate data. With Beacon active, the attacker gains full control. From here, they are no longer confined to one machine. They can pivot across the network, expand their reach, and strengthen their foothold. And here is the core truth. What began as a single shortcut clicked in one email now unfolds into a chain of control across an entire environment. One decision by a user becomes many opportunities for the attacker. The impact is not a visible crash or an alert. It is quiet persistence. The attacker now controls a flexible framework inside the environment, one they can use for espionage, for data theft, or for disruptive operations at a time of their choosing. Imagine your monitoring shows repeated connections to GitHub or Quora. Would you treat them as suspicious? Or assume an employee was simply browsing? That assumption is exactly what the attacker relies on. The strategy comes into focus. The attacker did not invent a new exploit. They combined a known technique, planting a malicious companion library beside a legitimate executable, with camouflage that hides their instructions inside the everyday web. Trusted platforms became their delivery infrastructure. The lesson is sharp. Attackers no longer need obscure servers or strange malware. They can plant malicious libraries beside trusted executables and then fetch their instructions from sites we all recognize. So the question is this: when your systems connect to GitHub, Microsoft Learn, or Quora, do you truly know what they are retrieving? Or do you simply assume it is safe? Check the episode description for detection strategies and indicators of compromise. If this story helped sharpen your perspective, share it with your peers, and subscribe for more episodes of the CyberBrief Project. Thank you for listening.